there boys and girls, and I want to welcome you to today's lesson only on iTTV, and you are with me, Mr. Joel, your tutor for Mathematics Form 4. Alright guys, today we're going to begin with Lesson 1 of Chapter 2, and the topic is called Quadratic Expressions and Equations. You'll be learning in this chapter two main parts. The first part is Quadratic Expressions, and the second part is Quadratic Equations. Today we'll be looking at Quadratic Expressions. And that brings us to our segment of Mathematics in Life. Alright, you might ask, what are quadratic expressions used for? And you might wonder, who is that man over there? Actually, this is a very famous Greek philosopher and a mathematician by the name of Diophantus, who lived in the 3rd century AD. And according to him, quadratic expressions are part of algebra, which is the branch of mathematics concerning the studies of the rules of operations and relations, and the constructions and concepts arising from them. So actually, algebra consists of a study of mathematics, and quadratic expressions are a part of this study. Alright, now, the first part is identifying quadratic expressions. What is a quadratic expression? According to the definition, any algebraic expression that has a variable that is squared and no other variables with power higher than 2 in any of the terms. The standard or the general form of a quadratic expression, ax squared plus bx plus c, where number 1, a, b and c are arbitrary constants, and the constant a cannot be 0, and x is the variable. Alright, there are a few more things to help you to understand how to identify a quadratic expression. Alright, let's look at this. An algebraic expression is a quadratic expression. Number 1, there is only one variable with powers which are positive integers only. Number 2, the highest power of the variable is 2. And number 3, the coefficient of the term where the variable has a power of 2 cannot be 0. Alright guys, seems like a lot here, but don't worry. How do you understand and identify a quadratic expression? It's quite simple actually. Alright, according to the definition that we have just learned just now, the general or the standard form of any quadratic expression is ax squared plus bx plus c. So all the points just now point towards a quadratic expression. What does it say? There must be only one variable, and the variable is most times represented with the letter x. What are a, b and c here? According to what we have learned just now, a, b and c are arbitrary constants. This means they can be any numbers, whether integers, fractions, decimals, positive or negative. Alright, the most important thing to identify from a quadratic expression is the power of the variable. The highest it can go is 2. It cannot be more than 2, and at the same time, the index or the power cannot be negative at any instant. So this is the general form of a quadratic expression. When you see an expression and it looks like this, that means that expression is called a quadratic expression. Alright, now, to familiarize with what are quadratic expressions, I have a few examples to show you actually. Alright, now, here are three expressions. And let's go through and run through one by one to understand whether all of them are quadratic expressions or not. Let's look at the first one. 2x squared plus 11x plus 3. Is this whole expression a quadratic expression? Yes, it is. Why? Because it resembles the general form of a quadratic expression, which is ax squared plus bx plus c. Can you tell which is a? In this case, it is 2. Can you tell it b? In this case, it is 11. And can you tell c? It is 3. And all these three numbers are called arbitrary constants. It means they are fixed numbers. Alright, it is a quadratic expression also because the variable, which is x, has the highest power of 2. So it is a quadratic expression. What about expression number 2? It is a quadratic expression. A is negative 3 over 2 and b is 7. So the highest power of x is still 2, but now c, although there is nothing, this means that the arbitrary constant c is actually 0. So the most important thing to remember that out of the three constants here, only a cannot be 0. B and c can take any value, wherever that is possible. And the third final expression on this paper, 9x squared minus 9x minus 4. One look and you'll be able to tell that it's a quadratic expression because it resembles the main general form of ax squared plus bx plus c. Check. X has the highest power of 2. Yes. A, b and c are there. It is a quadratic expression. So that is how you identify a quadratic expression, by using the checklist. Okay, using the variable, the constants, and the values of a, b, and c in the general form that is written on the board. Alright, now, you have learned what are linear expressions. And linear expression has a variable which is to the power of 1, that is the highest power. Quadratic expression is a step higher because the power of the variable is 2. Alright, let's look at this example. State whether each of the following expression is a quadratic expression in one variable. Alright, in A, the algebraic expression 3x minus 2. Is this a quadratic expression? Yes or no? Well, the answer is no. And what is the reason that this is not a quadratic expression? I'm sure you have known by now. The highest power of the variable is not 2. In the expression 3x minus 2, the variable, which is x, is to the power of 1 in this example. For it to be a quadratic expression, it must be with a power of 2. So not a quadratic expression. In B, the algebraic expression 5x squared plus 2x plus 1. Well guys, is this a quadratic expression or not? The answer is yes. Alright, you look at this expression and you can see that it resembles the general form of ax squared plus bx plus c. So because x has the power of 2 and everything else looks like the general form, it is because it fulfills all the requirements of a quadratic expression. Alright, let's move on to more examples. In C, the expression m squared plus 4 over m. Yes or no? Alright, one look and you can check. The variable, there's only one, which is m. The power is 2, but be careful. This is not a quadratic expression. Why? Because we have learned just now that the index or the power of the variable, in this case, which is m, cannot be negative. And every time you see a variable that belongs to a fraction, in this case 4 over m, the power is actually negative 1. So the whole expression is not a quadratic expression. And the reason is the term 4 over m has the variable m with power of -1. So not a quadratic expression at all. Remember guys, it must fulfill the requirements of every criteria of a quadratic expression. What about D? -3p squared plus 10. Alright, is this a quadratic expression or not? Alright, one look. Although it doesn't look like the general form of ax squared plus bx plus c that we have looked at the board just now, it is still a quadratic expression because it fulfills all the requirements. In this case, the variable is p and the index is 2. So yes. And the constant for p squared cannot be 0, which is -3, and only the constant b is 0. So that is not a requirement. So the whole expression is a quadratic expression. Alright, in E, you tell me 3 over 2 r squared plus 5s plus 7, yes or no? Is it a quadratic expression or not? Alright, take a look carefully at this expression. Yes or no? 3 over 2 r squared plus 5s plus 7. Alright, look there, there are two variables, r and s. So although r has a square, but this is not a quadratic expression because we are looking at quadratic expression in one unknown. It is not a quadratic expression. And how do you explain that? Because there are two variables, r and s, in the expression. Remember, there can only be one expression and one variable for each expression. Alright, and almost commonly you use x to represent it, but always other alphabets are also being used to represent any variable. Alright, now a quick test for you. State whether the following is a quadratic expression and give a reason for the case if it is not a quadratic expression. Alright, I'll leave you for some time. You attempt the questions. Alright, in A, -p squared plus 1. Yes, it is. All the requirements are fulfilled. In B, 4x cubed minus 2x squared plus 1. Yes or no? No, because the highest power in this expression is 3. It is a cube and not a square. In quadratic expressions, the highest index or the highest power for the variable is a maximum of 2. It cannot go more than that. So this whole expression is not a quadratic expression. Alright, look at C. -2 over 5 u squared plus 2v plus 1. It is not a quadratic expression. The reason being there are two variables, u and v. Remember, only one variable, only one alphabet. Alright, in D, t squared over 3 plus 2t minus 13, and it is a quadratic expression, yeah, because it fulfills all the requirements. Right? Remember all the requirements. And E, 7r squared plus 2r plus 45. One look, it resembles the quadratic expression's general form. Yes, it is, because all requirements are fulfilled. So you must know how to check whether a given expression is a quadratic expression or not. If it's not, state the reason to justify your answer. Alright, so today's exercise is mainly to identify whether a given expression is a quadratic expression. Now let's do this exercise together and you can give the answers before I read them out. State whether each of the following is a quadratic expression and explain your answer. Alright, 7m squared minus 3m plus 8. For the expression in A, yes or no? Is it a quadratic expression? Yes, it is. And the reason, it fulfills all the requirement. And remember the requirements? The variable in this case, which is m, is squared. And the constant a is 7, b is -3, and c is 8. So always compare the quadratic expression with the general form of the quadratic expression, which is ax squared plus bx plus c. Remember, you must always check whether the variable, which is x, or it can be y, a, b, or c, any alphabet. It must be only one alphabet to represent the variable in any one expression. And at the same time, the power must only be 2. Cannot be 3, cannot be a negative integer. And at the same time, take a look at all the constants. A, B, and C. Yeah? Only A cannot be 0. B and C can take any possible value. So compare the quadratic expression with the general form, because the general form will tell you whether it is a quadratic expression or not. Alright, now in B, is the expression r squared m plus 2r minus 3 a quadratic expression or not? Answer? No. What is the reason? State it clearly. Although there is a square, but one look, there are two variables, r and m, and because they are different, it is not called a quadratic expression in one unknown. Alright, next, the algebraic expression minus 6t squared minus t. Is it a quadratic expression or not? Can you compare it with the general form? And it is a quadratic expression. Alright, because the same reason, once the quadratic expression fulfills every requirement that we have looked on just now, it will be a quadratic expression. In this, the variable is represented by t, and there are no any other variables besides t. And t has a power of 2. And check the constant for t squared is -6. It is not a 0. Okay, so the rest minus t, the whole expression will belong to a quadratic expression. Alright, what about s over 2 plus 2 over s? Nah, it's not a quadratic expression. Why? Because anytime you have over s, over a variable, it will not be considered a quadratic expression because the index is -1. Okay, and E, k squared plus 2 over k plus 6, also no. Why? Because you see there's a k that belongs to a denominator of a fraction-like term. So it has a power of -1, it doesn't fulfill all requirements. The reason the variable has a power of -1. What about f? U squared plus v squared plus 3. Alright, it is yes or no? Not a quadratic expression. And what is the reason? You might tell, it may be, but it's not. Why? Because there are two variables. Look carefully at the variables. U and v are totally different. So it is not a quadratic expression in one unknown, although the power of the variables is 2. So all the conditions need to be fulfilled at the same time for it to be a quadratic expression. So the reason, we have looked at it a few times already, there are two different variables, being u and v. Alright, so today we have learned what are quadratic expressions. Alright, and quadratic expressions is a branch, alright, of mathematics that belongs to algebra. Alright, let's recap what we have learned today. Alright, so the general or the standard form of a quadratic expression is the all-important form of ax squared plus bx plus c. Alright, and the three different colors are there to show you the difference. Remember, A and X, B and C, they are not variables. There is only one variable for each quadratic expression, and that is X. Can it be represented by other letters? A, B or C? Preferably not, because you use A, B and C to represent the constant. So if you want to represent the variable with another letter, choose X, Y, Z or any other alphabet besides A, B and C. And then secondly, check, is the power of the variable 2 or not? If it is 2, yes, it is. Alright, the power of the index must be 2, but it cannot be more than 2, it cannot be less than 2. It must be 2. And the third checkpoint, make sure that the constant for the term of the highest power, which is the square, it is not 0 at all. And we have looked at many examples here and on your screen about how to identify quadratic expressions. Alright, so today, to conclude, we have learned that quadratic expressions are part of algebra, and it is used in computation that involves a lot of operations. This is actually just the beginning of algebraic expressions. Alright, as we progress, you will learn the use of quadratic expressions more and more. So I thank you for listening, and that it goes for today's lesson. I'll see you in the next one. Thank you.